Okay, lesson 6, product and quotient rules. So I kind of indicated yesterday when we got towards some of those pieces at the end, there were some pieces I'm like, wait, we don't know how to do this. We don't have the right rule yet. But then, okay, we were able to use our log rules and pull the powers out front, separate them into separate logs, those type of things. So it did work. Now, what we're looking at today are the product rule and quotient rules. We're adding to our, so to say, derivative toolkit, okay? There are some times, like as we look at this first one option to do this would be we could FOIL it out and then take the derivative of each term using what we already know, using just our power rules. However, there's something called a product rule. And, okay, even though it wouldn't be necessary on A, B, okay, I could distribute that out. C, there's two different functions happening there. Okay, and so our product rule is what we use when we have two different functions being multiplied together. Okay, if you have terms being added together, you just take the individual derivatives. If you have terms being multiplied together, we're going to use something called the product rule. The product rule, if a function is the product of two differentiable functions, then the derivative is the first, basically the first function, times the derivative of the second, plus the second times the derivative of the first. So that's saying if you have two pieces, and I'll be honest, I probably usually kind of do that the opposite of what that one reads, but it's saying take the derivative of one, keep the other, plus, and now flip-flop it. Whichever one you didn't take the derivative of the first time, we're taking the derivative now, and we're keeping the other original piece. Okay, so this is a product rule. Anytime we have two things being multiplied, so two x-type things, x-type pieces, we're going to use the product rule. In symbols, the derivative of f times g is f times the derivative of g plus g times the derivative of f. Okay, and for product rule, it doesn't matter which order you do that in, right? Or f prime times g plus f times g prime. And you will notice that that is kind of flip-flopped there. Here's the other version, right? The derivative of f times g, derivative of the first, times the second, plus the first times derivative of the second. It's all, well, here it's doing keeping f and then g prime, whereas here it's f prime and keeping g. The idea, when we get to quotient rule is more specific. Product rule, adding is commutative, multiplying is commutative, so it doesn't really matter the order we do this in. That's what it comes down to. If we use some shorthand, basically without the x's, if h is f times g, then h can be f times g prime plus, depending which way I want to write it, g times f prime, or h can be f prime times g plus g prime times f. I don't know why, I really struggled to write it out in the symbols because I just know how to do it. You know, so I struggled to think about which way I'm writing it. Okay, so get that written down. Let's try A. As I said, if you don't want to use the product rule, I'll be honest, I don't think I would use product rule on this one. Maybe I'll change my mind after today, but me personally, before when I've taught calculus in the past, I would say let's FOIL this out and then take our derivatives. You'd have, it's a FOIL problem, right? You'd have 3 terms, take the derivative of each term. However, we're going to experiment with product rule. So, you ready? F prime of x. I'm going to take the route of, hopefully, the derivative of the first, keep the second. So what's the derivative of 2x minus 1? 2. Times, we're going to keep the x minus 4. So derivative of the first one, derivative of 2x minus 1 is 2, keeping x minus 4. Because it's product rule, we're going to add. Now we're going to do the opposite of that. We're going to keep the 2x minus 1. And what's the derivative of x minus 4? 1. That's the product rule. Now, what are you expected to do most of the time? Usually you're not just going to find the derivative and be done when we get farther into calculus. You're going to do other stuff with it. So we're going to clean it up. So if I distribute 2x minus 8, distribute the 1, 2x minus 1, clean up like terms. Four x minus 9, I believe. Questions? Now, I will say, her work might look a little different, right? Maybe when you look at that answer key, maybe they did keep the 2x minus 1, derivative of x minus 4 first, right? So you're going to have to look to match up pieces when you start checking the answer key. And even if I put my answer key on there, you're still going to have to look to match up pieces because, you know, there's different pieces we could use here. Okay, let's try B. Y prime. Derivative of the first, keep the second. So what's the derivative of x squared plus 3x minus 1? Good. 2x plus 3 times, I'm going to keep 2x squared minus 5. Product rule says we're going to add. And now we're going to reverse the situation. I'm going to keep x squared plus 3x minus 1. Derivative of 2x squared minus 5. 4x. You guys appear to be okay with these basic derivatives. Good, that means the homework worked and you got the rules stuck in your head. From here, we multiply it together. Okay, and I don't know, maybe it would have been better if we would have FOILed to begin with and then just taken the derivative. And this is where, as we get farther on, that'll be your choice, right? Today we're practicing the product rule, so I'm going to do that. But in all honesty, I don't know that I'd put this type of problem in a product rule, so. But we're learning. Okay, if we FOIL the first, 4x cubed minus 10x plus 6x squared minus 15. Then I'm distributing 4x. So plus 4x cubed plus 12x squared and minus 4x. You got the same pieces as me? Maybe not in the same order, but the pieces. And then like terms. Y prime is 8x cubed plus 18x squared minus 14x minus 15. Now, I'm just actually kind of looking at my notes here. I hadn't really looked at my notes. Realize, depending on the situation, this first answer, had we taken the derivative?
Yes.
That first row. That is a derivative, yes? Could you technically leave it like that? Yeah, depending on the situation, okay? Depending on the situation, you can technically leave it like that. When you're looking at multiple choice AP, it's, okay, take the derivative, but then kind of look, okay, what form are they looking for, right? When it comes to taking the derivative within a bigger problem, it's, okay, where's my goal here in the end? Do I want the simplified derivative? Do I not need the simplified derivative? So realize all three of these lines are equivalent. I'm just kind of, you know, I think natural form in all of us, or at least me, I would probably assume yes, is to clean it up. So I'm still going to encourage that. Okay. Move off polynomials a little bit and try one with trig functions. Okay. Do you see the two pieces being multiplied here? I mean, basically, there's a sine x and a cosine x, right? Now, that 2 could go with either piece. Logical to me is say that we're thinking of this as 2 sine x times cosine x. Okay? So, ready? Okay. And then realize that 2 is just going to be in front of each term. Because when I say, what's the derivative of 2 sine x? Well, it's going to be 2. What's the derivative of sine x? Cosine x. So the derivative of 2 sine x is 2 cosine x times the other cosine x that's still there, correct? Product rule says we add. And now, this time, I'm going to keep 2 sine x. What's the derivative of cosine x? Negative sine x. Clean it up, of course. Two cosine x times cosine x, 2 cosine squared x, minus 2 sine squared x. I could factor the 2 to the front if I wanted to, and say 2 times sine squared minus cosine squared x. I'm just going to leave it like this. Okay, one more in this page, or in this section, I should say. G prime of x, you see the two pieces being multiplied, right? Derivative of 1, keep the other. So derivative of 3 to the e, 3e to the x minus x squared. So derivative of 3e to the x is 3e to the x minus derivative of x squared minus 2x. Keep the original, or the other piece, x cubed minus 1. Plus, okay, this time I'm going to keep 3e to the x minus x squared, derivative of x cubed minus 1. Three x squared. Okay, this is one. I debate which way to take you. This actually almost might be one of the best ways to leave it. Okay, I actually have this underlined in my notes, but then I also have it multiplied out in like terms collected. Here's the deal though. When we multiply this out, there's not going to be a lot in the way of like terms to add. It's not going to clean up a ton. And so, I guess I do get it down to 5 terms, but what'd you say? You're good leaving it like this?
You have 4 terms there, so.
I say about 5 terms being added. You guys want me to leave it like this?
Yeah. Yes.
Okay. We'll stop there then.
Wait, how would you multiply the 3e to the x and the x to the third? When you just.
Yeah, I don't like
No.
Yeah, we're looking at okay.
Okay, and maybe we should just so you guys can see it. But yeah, so you guys heard Peyton's question, right? How do you multiply 3e to the x times x cubed? You'd write it as 3e to the x, x cubed. And so for there to be a like term and add that with something else, you'd have to have another e to the x, x cubed term. We're not going to have another e to the x, x cubed term. Okay? So yeah, it gets kind of, there's going to be an e to the x, x squared term down here. There's going to be x to the 4th terms. There's going to be x terms, like, yeah, it's, okay. We good then? Okay. Since multiplication and addition are both commutative, the product rule is hard to mix up. Unless you misunderstand the rules, it's easy to just take turns on the factor, one derivative at a time for each term. Okay, and I know you guys are probably, for the most part, you're kind of following me there, but you'll figure it out as you go, right? And you get to work on your own. One derivative, keep, and then plus, and then flip-flop. Okay? Now, word of caution here. Don't confuse the product rule with limit properties. Okay? The product rule is incorrectly interpreted as the derivative of a product of two functions f and g is the product of the derivatives of f and g. In other words, what we cannot just do is we cannot say derivative of the first term, derivative of the second term. Okay? That's not how the product rule works. Now, going forward as we put this all together, I'll be honest, that's what's going to happen. You guys are going to make that mistake of, oh, okay, I'm going to do the derivative of this piece, derivative of this piece. And you're going to forget to do the product rule of derivative of one, keep the other, and vice versa. So you do have to watch out. Okay? I can't just say, oh, f times g, derivative of that is derivative of f times derivative of g. Okay? So that's a big no-no there. So watch out. Don't let it trick you. Although, you know, are you really a first-year AP Calc student if you don't make that mistake at least once? So just make it on the homework, though. Okay, that's product rule. We'll put this all together later on. But now we've got to talk quotient rule. Quotient rule, of course, is if you have two pieces being divided. Same thing as what I just warned you of. The quotient rule is not derivative of the top, derivative of the bottom, put them over each other, we're done. Okay, the quotient rule is a little more than that. If a function is a quotient of two differentiable functions, then the derivative is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. Okay? I know, there's a lot there. Again, I tend to flip these pieces. I tend to say the derivative of the top times the bottom. That's this right here, right? Minus. Okay, guys. That should be logical to you, yes? Product goes with multiplication, quotient goes with subtraction, but you have to remember that's a minus sign there. So it's derivative of the top times the bottom. Minus, now it's derivative of the bottom times the top. Because that's subtraction on top, that order matters, right? I can't just take whichever derivative I want first. I have to do derivative of the numerator first. It's over the denominator squared. That is, of course, assuming the denominator is not equal 0. This one's in the notes. I'll be honest, I don't ever use this one. However, if we watch AP Live videos and stuff, I don't know if Mark sings it as much, but Verge uses this more. Those are the two people that do the AB Calc videos. And so the derivative of high over low. So low d high minus high d low over low low. As in, low, you keep the bottom, d high, derivative of the high, minus high, keep the high, over derivative of the low, over low low. I see how it works. I'm not a singer, so, you know. But yeah, you can, low d high minus high d low over low low. Virtual singing, I know, so. And of course, assuming the denominator is not equal 0. High representing the numerator, low representing the denominator. Good enough? Okay, so that is, if you want a, how do I spell it? Mnemonic. Okay, there's your mnemonic for this section. If that is your type of thing. Earlier I gave you a shorthand for the product rule. So if I give you a shorthand for the quotient rule, H prime is going to be F prime G minus G prime F over G squared. Okay, and of course they always throw in as long as the denominator does not equal to 0. Okay. As much as I wanted to FOIL earlier and take the derivative, That doesn't really work here, does it? We have to use the quotient rule. So let's jump right in. Derivative of the numerator. Derivative of 2x cubed plus 4x squared minus 7. What you guys got there? Okay. 6x squared plus 8x, that's derivative of the top, times the bottom. It's a quotient rule, so now I'm going to subtract, and now I reverse it. What's the derivative of the bottom? 1 times the numerator, 2x cubed plus 4x squared minus 7 all over x minus 5. Oh yeah. Don't ask. Oof. First one, I'm going to mess it up. Denominator squared. Glad you guys read the rule. Okay, now, in terms of these, we are going to clean this one up. I'll be honest, we won't always clean all of them up. You can get some really nasty quotient rules, so you won't always clean them up. We are going to clean this one up now. Can I cancel those x minus 5s?
Yes.
Okay, that's good. That's good. You should be saying no. Okay? We should be saying no. And I just, I want to make a point of it because we have to, even as calc students, I want to remind you guys. I'm not canceling an x minus 5 here and an x minus 5 here because it's subtraction, right? Remember that rule? You can't cancel a factor if it's only in part of an addition or subtraction problem. Now, if there's also an x minus 5 over here, then yeah, we'd have an x minus 5 in the front term, an x minus 5 in the back term, an x minus 5 on bottom. We can cancel it. But just a reminder, okay? Okay, let's multiply that top out. I'm foiling first. 6x cubed minus 30x squared, right? Yeah. Plus 8x squared minus 40x. The second one, it's a 1 just multiplied in, but it is negative. So minus 2x cubed minus 4x squared plus 7. Denominator, we usually leave. Did I leave it? Yeah. Denominator, we tend to leave more in a factored form unless we have a reason to multiply it out. Okay? If there's a reason, we could do that, but we tend to leave it more in the factored form. Okay, clean up. I see 4x cubed minus 26x squared minus 40x plus 7 over x minus 5 squared, barring I didn't make any mistakes. Hey, it agrees with my answer key. This is why I work these out ahead of time, right? Now, obviously, if it looks like the top would factor or something and we might be able to do something more, we'd want to do that. But, yeah, that top looks ugly, so we're going to leave it. Okay, ready to try? B? G prime of x. Derivative of the top. What's derivative of e to the x? to the x times x squared plus 1, keeping the denominator. And then we're going to say minus. And now it's going to be derivative of the denominator. What's the derivative of the denominator? 2x times the numerator. All over x squared plus 1 squared. Okay. I am going to go a little farther with this one, I think, because there is a little bit of cleanup to do, or that you can do. Now, can I do it all in one step? Okay, if we look at the top as is, what do you notice here? If I take this e to the x and I'm going to distribute it to x squared and to the 1, yes? What do you notice about this piece over here? There's also an e to the x. So if we multiply this out, there's going to be 3 terms on top, and they're all going to have e to the x. Where do you see me going with this? I'm going to factor out a GCF of e to the x. Now, when I factor out that GCF of e to the x, I'm still going to have the x squared plus 1, and I'm going to have a 2x. Yes? So I'm actually going to write it in the order x squared minus 2x plus 1. Now, my reason for doing this? If it was helpful, that numerator actually factors now. X squared minus 2x plus 1 factors. Okay. In our situation, it's not going to cancel with anything in the denominator, and we're not going any farther with this problem. It's not like we're trying to work with it or anything like that. But on my answer key, I have that you could have that answer, or you could say e to the x, then x squared minus 2x plus 1 is x minus 1 times x minus 1. So x minus 1 squared over x squared plus 1 squared. Okay, so either or are good there for various reasons. And hey, maybe you never even multiplied out. Maybe you left it as the original. That's a possibility too. Okay. Did you follow how I did that? Did I talk about it slow enough that we were okay there? Okay. Stop me if not, because I can always write it out. And I will be curious when you guys view the provided answer key, which of the steps, because there are a few that you guys aren't going to like what she skips, I don't think. But that's what I'm here for then, right? Okay, C. Tell me what I'm doing. Okay. Derivative of ln x is 1 over x. Then what? Times the x minus 2. Then what? Then minus, okay, she says 1 as in derivative of x minus 2 is just 1 times ln x. All over x minus 2 squared. Okay. I would probably not leave it in this fraction. Actually, I definitely would not leave it in this fraction, or in this form, because we've got fractions within fractions.
Can you take the derivative of x then?
Again?
I meant the end.
No. You have to leave it. Because we've already, that's the piece that we had to keep this time. So we don't want to take the derivative. if let's see, I think I'll have you, okay, go ahead and distribute the top. What is 1 over x times 1? Is that what I said?
Yeah.
Okay, let me try that again then. What is 1 over x times x? 1, yes, because the x's cancel. Obviously, I did not say what my brain thought I said. Okay, thus the answers from you guys. Got it. Okay, and then minus, what's 1 over x times 2? 2 over x. And then minus 1 times ln x is just ln x over x minus 2 squared. Okay. Not that you couldn't necessarily leave it like this. However, how do we fix this issue of having a fraction in the numerator of a fraction? Okay, so there's an x in the denominator, in this denominator that we want to get rid of, yes? So to get rid of the denominator of x, you multiply by x, which means we're going to want to multiply the numerator of the fraction by x. What you do to the numerator of the fraction, you do to the denominator fraction. Can I multiply by x over x? I can't, because I'm multiplying by 1. That's all I'm multiplying by. When I multiply by x over x, I'm multiplying by 1. And what it does is cleans this up a little bit, gives it a little bit nicer look. Now you have to distribute the x everywhere, right? So on top, x times each of those 3 terms. So on top, I get x minus 2 minus x ln x over x times x minus 2 squared. On x ln x, always put the x out front. You don't want to put it at the back because then is it with the natural log or not. And on bottom, I would multiply the x in by any means, just make it x times x minus 2 squared, quantity squared. Okay? That would be your more acceptable final answer there. Okay, D, back to the trig. Derivative of sine over 1 plus sine. Excuse me, 1 plus cosine. Okay. What do we got? Derivative of sine x is cosine x times the denominator, so times 1 plus cosine x. What goes next? Minus, because it's a quotient rule. And now, you can put either piece first. Derivative of 1 plus cosine x. Yeah, negative sine x times the numerator sine x. All over 1 plus cosine x quantity squared. Okay, I do want to clean this up because if I recall, there's a good cleanup we can do here. There's actually several cleanups, and this is something you'll want to start watching for as we dig deeper into these. So let's go ahead and multiply that top out. Cosine x times 1, cosine x, plus cosine x times cosine x, cosine squared x, minus negative sine x times sine x is going to become what? Plus sine squared x. Because minus a negative is going to make it positive. Sine times sine, sine squared x. Over 1 plus cosine x, quantity squared. I don't want to stop there. I see something.
Isn't the 1 plus cosine squared?
No. Not in that form, it's not. I'm trying to think. No, I see something in the numerator. From the purple paper, might I add, though.
Your
Oh,
cosine, two square terms. Well, yeah.
What do you know about cosine squared plus sine squared x? Equals 1, right?
That's crazy.
One of our Pythagorean identities.
That's some good stuff.
It keeps coming back, guys. We're not done with that purple paper, okay? So do I need to pull some of the purple papers out from last year, maybe? I'm sure they're down there in my cabinet. I never throw them away because I hold on to the extras. That way Ethan's not the only one with the purple paper laying around. Okay, guys, Pythagorean identity. So I can rewrite this as cosine x plus 1 over 1 plus cosine x quantity squared. What if I say I'm not done again? The numerator is cosine x plus 1. That's the whole numerator, right? So that whole numerator of cosine x plus 1 can cancel with another cosine x plus 1. Do I have another cosine x plus 1? Yeah, it's in the form 1 plus cosine x, but I do. So this guy can cancel with one of my denominators, yes? And so when they cancel, I'm going to end up with 1 over 1 plus cosine x. Okay. So the trig rules, keep them in mind. Be happy it's just a Pythagorean identity they throw in. There are times some of the other ones that we're less familiar with will pop up too. Okay. This is one I can obviously recognize and it comes very easy to me. There's some that I'm like, oh yeah, I think that's one. Okay, so we're going to have to definitely review those. Okay, guys, I already mentioned this, but just, highlighting it. Subtraction is not commutative. You cannot flip around the pieces in the numerator. You'll find that out real quick. Okay, so you have to be careful with the quotient rule. The quotient rule is not to be interpreted as the derivative of a quotient of two functions is the quotient of the derivative. So, and again, it's not just I can't do the derivative of the top, derivative of the bottom. Okay, so kind of the same thing we talked about with the other one. Now, this is another just fun one thrown in there that I guess someone came up with. They threw it in there. I hadn't heard this one before, but instead of high over low, high over ho, so it's ho-de high minus high-de ho over ho-ho, and ho can't equal 0. So, take it or leave it. It's thrown in there.
Wait, could you run that back? What was it again? It was
You were going to read it.
Hody high minus Heidi ho.
I feel like I think you could flip that around really easy.
I know. You could, yeah. I agree. Okay, where am I at time-wise?
A minute, 2 minutes, 3 minutes.
4 minutes. Couple minutes.
What is this guy? Okay, so we can at least think about this one. No? Find an equation of the tangent line to the graph at this point. What are we going to be doing when we start tomorrow? Yeah, derivative of the tangent line is the slope. So we're going to find derivative. And that's going to be our slope. We're going to have to find it at that point. We have the point. So how about you guys can start that tomorrow when I'm getting attendance?
Is that our bell ringer?
Sure. You guys can do that.
Yes.
I mean, come